Welcome to solverfy.
35.70, so we've got a couple pieces of glass forming an air wedge, which causes thin film interference. Our light is monochromatic at 620 nanometers. And initially we have a dark fringe over here and a bright fringe over here with 9 dark fringes in between them. And at time 0 we start closing the gap between them such that the rightmost fringe changes from light to dark and back every 15 seconds. So the first thing we want to know is the rate at which the right end is moving. So for this we have m naught, the initial m is 9.5. To d naught is going to be m naught lambda. We have a delta t of 15 seconds. And so then our next value of m will be 9. And 2d prime equals m prime lambda. So the change in the spacing, and we just care about the absolute value of it, is going to be the initial separation minus the next separation. This will be 1/2 m naught minus m prime times lambda. This is 155 nanometers. And so then the rate is just the distance it travels and the time it's traveling, because we're told the rate is constant. And so it's moving at 10.3 nanometers per second. So far, so good. Part B, we want to find out how much the spacing has changed at the right end when both the left and the right ends have a dark fringe and there are 5 dark fringes between them. So in this case, the final value of m is 6. So our change in spacing, an absolute value, because this is going to be positive. Usually, the change is final minus initial, but if it's going to be negative and you want the absolute value, you just multiply it by -1. So again, this is just 1/2 times the difference in the values of m times the wavelength. And so this is 7/4 of a wavelength, or putting in our value for the wavelength. This is 1.09 microns.